In Activity 6, Ocean Waves, students learn what causes ocean waves to form and how they move. They first observe how waves are produced and identify the parts of a wave. Students then model the movement of waves and discover that a wave travels forward, but the water does not. You will need the following materials from the kit: Activity Sheet 6, paint tray, plastic bead, blue food coloring, and corn oil. You will also need to provide pencils, rulers, 1-liter plastic bottle with cap, paper towels, 2-quart pitcher, and tap water. To prepare for this activity, make a copy of Activity Sheet 6 for each student. Make a wave bottle by filling a 1-liter soda bottle 1/3 full with colored water and filling the rest of the bottle with light corn oil. Screw the cap on tightly and let the bottle sit upright so that the two liquids separate. For this activity, you will also need a ruler to use as a straight edge, a pitcher of water, and a bead for the wave bottle. Each student will need a ruler, and each team of 4 will need a paint tray and about 1.5 quarts of water. Make sure to have some paper towels available in case of spills. To begin the activity, invite students to share their experiences with water waves in the tub, in a pool or lake, at a water park, or at the ocean. Ask students, what is a wave? Guide students to understand that a wave is a ridge or swell moving along the surface of a body of water. Then ask, how do you make waves in the tub or in a pool? Students will probably respond they make waves by pushing water with their arms or legs. Hold up the wave bottle for all students to see. Turn the wave bottle on its side, then rock it gently to make waves form inside. Pass the wave bottle around to give students a chance to play with it. Then ask, what causes waves to form inside the wave bottle? Students should identify the force of gravity as well as the walls of the bottle, which cause the oil and water inside to slosh about, forming waves inside the bottle. Explain that waves form in water when a force pushes, pulls, or in some other way disturbs the water. Ask students, what do you think causes waves to form in the ocean? Students may mention passing ships or sea life as possible causes of ocean waves. They may also suggest underwater earthquakes or volcanic eruptions. Some students may know that wind causes most ocean waves. Accept all answers. Next, distribute a copy of Activity Sheet 6 and a ruler to each student. Divide the class into teams of 4 and distribute a paint tray to each team. Point out the shape of the tray and ask, how is this tray shaped like the ocean floor? Guide students to realize that the inclined bottom of the paint tray resembles the continental shelf, continental slope, and abyssal plain. Fill each team's paint tray with about 1.5 quarts of water. Tell students to tap their fingers in the water at the deep end of the paint tray and observe what happens. Help them understand that tapping the surface of the water causes ripples to form. Next, have students blow gently on the water at the deep end of the paint tray. Ask, what happens to the water now? Again, students should identify ripples forming and traveling to the shallow end of the tray. From this demonstration, students should conclude that wind causes waves. Then ask, how do ocean waves travel? Students should note that ocean waves travel away from the source of the disturbance toward shore. Next, instruct students to blow harder and longer across the surface of the water and observe what happens to the size of the ripples. Inform students that the harder and longer the wind blows and the greater the distance over which it blows, the larger the waves become, just as in their experiment. Help students understand that ocean waves can vary in size from very small ripples caused by mild breezes to hurricane-generated waves more than 30 meters high. Then, using figure 6-1, instruct students to identify and label the crest or highest point and trough or lowest point of the wave. Then ask students, how would you measure the height of a wave? Students should respond that the height of a wave is measured vertically from the trough to the crest. Then ask, how would you measure the length of a wave? Students should understand that a wavelength is the horizontal distance from crest to crest. Next, drop a bead into the wave bottle. After the bead has settled between the layers of oil and water, rock the bottle gently to form waves inside. Students should notice that the bead is lifted temporarily by the wave as it passes and lowered again. The waves move from one end of the bottle to the other, but the bead does not. Tell students to answer questions 5 and 6 on the activity sheet. Then ask, what do you think happens to water molecules as the wave passes? Students should infer that the water molecules are temporarily displaced as the wave passes, but do not move forward with the wave. This displacement of water is what causes boats and water birds to bob up and down in the water without getting washed into shore. Next, ask, what do you think would happen if water traveled with the wave? Guide students to understand that the water would drain from the ocean and collect on the land. Finally, ask students what happens to waves as they reach shore. Students who have been to the beach will know that waves break as they approach shore. To demonstrate, hold up the wave bottle and rock it again. Ask students to notice what happens to the waves as they reach the ends of the bottle. Inform the class that waves that fall over are called breakers. Ask what causes the waves inside the bottle to break. Students should note that running into the ends of the bottle caused the waves to break. Ask, what do you think causes ocean waves to break? Guide students' attention to the shape of their paint tray waves as they approach shallow water. Tell them that the friction of the ocean floor slows down the bottom of the wave, but the top of the wave keeps moving forward. The top of the wave then moves past the bottom, and the front of the wave gets very steep. Eventually, the wave topples over on itself, forming a breaker. And unlike in the wave bottle, waves in the ocean break forward in the direction in which they are moving. Instruct students to use their rulers to help them complete the diagram at the bottom of the activity sheet. Finally, let students know that in the next activity, they are going to learn about another way in which ocean water moves, in currents. To conclude the activity, rinse and dry the paint trays and return them along with the food coloring and oil to the kit. Leave the wave bottle out on display. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.